Okay, this lesson is going to discuss the parent graph of absolute value and how to shift it, left, right, up, down, stretch it, compress it, reflect it, and talk about the characteristics of all those graphs. So the absolute value graph is going to have these bars around the x, and absolute value simply means that whatever you plug in for x is going to be the positive result. So if I plugged in -2, then that output would be +2. So you'll see on the graph, it's going to look like a V. At the point -2, its output would be 2, whereas at the point +2, it's still going to be 2. And so that it'll almost be like a reflection where the y-axis is a line of symmetry. And the point 1, 1 exists, as well as the point -1, 3, 3, and -3, 3. And of course, when you plug in 0, you get 0. 0 is neither positive or negative, but the absolute value of 0 is 0. So it's going to have a V shape. And I want everybody to go to Desmos.com and click on Graphing Calculator and make sure we can verify how to input it. And there's a couple directions here I have for you. When you go to Desmos, I like keyboard shortcuts. So what I press is when I want to put the function in, I'll say, you can put f of x, f parentheses x, or you can put y equals. I'll just put f of x so you can kind of get used to that function notation. And I will press shift and the button below backspace, which is, I guess, a backslash, and you can put the x right in there. You can also access that. You can also access that by clicking the calculator down here, and you'll see the absolute value of a, and that'll put those bars there too. So let me do full screen on the graph so you can see it. And you can verify that it's going to be the same points here, and you can click on it. You know, it's got a minimum value at 0. It hits the x-axis at 0, so it's 0 is also 0. Got the points 2, 2, -2, 2, and of course, if you zoom in, you can see the other points 1, 1, -1, 1. So it's got all the same points that we had before. I want to verify a couple things with absolute value graphs. I want you to write these down. They're going to have a few key characteristics that we want to talk about. So the first thing is they all are going to have a vertex. Sometimes it's the minimum and sometimes it's the max. So for the parent function, the vertex is going to be the minimum. That's going to be right here. That's going to be 0, 0. Now, if you have a flipped one, in some cases we do, then it would be a maximum. But in this case, it's a minimum. They also have a domain. The domain is whatever x values can be plugged into it. And you can plug in any number into the absolute value graph. These go on forever, left and right. And normally you would see arrows on them on a printed out graph. So the domain is going to be all real numbers. The way you're going to write all real numbers for our purposes is going to be parentheses -infinity, comma, +infinity, close parentheses. It's the same terminology, but that's called the interval notation, and that gets used more than just saying all real numbers. The range can be tricky. If you start throwing around different ways to reflect it and shift it up and down, then that will change the range. But the range is basically whatever y values. So the y values in this problem, well, the lowest y value happens to be right here at that minimum. And of course, that point is 0, 0. So the range is going to be all real numbers greater than or equal to 0. So you can say it a couple ways. You can say y is greater than or equal to 0. Or you can start with a bracket. Brackets include that point. So if it's if it's going to be equal to it, then you want to put a bracket, not a parentheses. So you start with your smallest number, and then you end with infinity. Infinity always gets the parentheses. So the range is going to look like those. The graph can be, there's going to be part of the graph that's increasing, part that's decreasing, and there also are going to be zeros. So the increasing part, and again, the parent function, the increasing part is going to be the part that basically has a positive slope. So that's going to start at 0. We always use x values. So at 0, the graph begins to increase as it goes to the right. So from 0 all the way till forever. So that's going to be increasing from when x is greater than 0. Or you can simply say parentheses 0 to infinity. Don't put a bracket on that for the increasing decreasing interval, just use parentheses. So it's from 0 to infinity that's increasing. The decreasing interval will have the negative slope, so that's from the left side all the way until it hits 0. So you would say x is less than 0, or start with negative infinity, comma 0. So you basically put the 0 on the right part of the parentheses, but the negative infinity goes on the left. A 0 is where it touches the x-axis. You might refer to them as x-intercepts. Not the same as y-intercept. Sometimes they don't have them, so you can shift it up and it wouldn't cross the x-axis, but here it does cross the x-axis one time in this case. So it's going to have an x-intercept of 0, so its 0 is going to be, you could say 0, 0. I think a lot of times it's just the 0 is the x value, so we talk about 0 being what value of x gives you a y equals 0. So 0 would be the 0 in this case. Now you can do a lot of things with transforming these. So let's talk about that. So for example, if I want to take this graph and move it to the right, then you can play around with the numbers inside of the absolute value bar. So y'all type this in if you haven't done so yet. And inside, I want you to do minus a number. So let's say we do -2. That's going to shift that graph 2 units to the right. And if I wanted to go left, I could say like +2, and that would shift it 2 units to the left. So the function notation for left and right is the opposite of the sign that the x-axis has. So it's positive sign here, right's going to be -2. It's a negative sign here, left's going to be +2. So that's kind of reversed. So let's talk about that. So if it's going to go 2 units to the right, that function notation would be inside of the brackets, so inside of the absolute value bars, x minus 2. We always subtract for right. If it's going to go left, so for this example, if I'm going 4 units left, then it'll be adding inside the groups, so +4 inside the absolute value bars. Now let's talk about up and down. So if I want to move it up and down, then what I need to do is I need to close the absolute value bar first. And then at the end of it, I need to add or subtract. So adding, like adding 4 will bring it up 4. Notice it's still opening up, but it got shifted up. Whereas if I wanted to go down, I might say minus a number. So if I did like -5, it would be shifted down 5. Notice when I do that, it has a new vertex. Its minimum is now 0, -5. That changes. It's got different zeros. It crosses the x-axis at -5 and +5. So its zeros can change, and you can click on those points to get the zeros. You don't have to calculate those by hand right now. So talking about how that moves, up 3 units would be close the bars, add 3. Always add outside if it's going up. Down, close the bars, subtract. Always subtract outside if you're going down. A couple other things we can do. If I want to transform it by reflecting it over the x-axis, then what I'm going to do is I'm going to put a negative number right next to the 0. If you put that dash there, that's a negative. That's multiplying it by -1. That's not changing the shape of it, but it's going to make it open downwards. So instead of having a minimum now, it has a maximum. Okay. Instead of its range being y is greater than or equal to 0, its range is now y is less than or equal to 0, and that can change depending on the y value. So if I want to reflect it, I'm simply going to put a negative on the outside and lead with that. If I want to stretch it, then I'm going to lead with a number on the outside that's bigger than 1, so 2. I could also lead with a number that's less than -1, so -2 would be stretching it. Stretching it vertically means it's going to be narrower. So that, as long as that number is bigger than 1, technically I could do 1.1, and that's not a whole lot bigger, and you might not notice it on here, but it is a little bit of a stretch rather than -1, or -1.2. And you can actually play around with it. Something really cool that I've noticed, you can put like a little if I type in A and it'll say add slider, I can kind of see what happens. So the higher that gets, the more narrow it becomes. And of course, in the negative direction, that is true as well. So -10s are real narrow, then stretched vertically, but it's also then reflected. So to recap on that, doesn't matter if it's positive or negative, but that number after the negative, if there is one, has to be larger than 1 to be a stretch. So what's going to make it compress or be wider is you'll have a number that is between -1 and 1. So if it's -0.9 or positive 0.9 or 1/2 or 1/3 or -1/3, any of those numbers that are basically between 0 and 1, whether they're positive or negative, would be a compression. So I'm going to modify my slider, and you can actually click on here. If I'm clicking on that -10, I'm going to say -1 for my lower end and +1 for my upper end. And I'll make my step go like by 0.1, so you can see what's going on with that. So when it's -1 or 1, it doesn't get compressed, but anytime it's below that, see it's getting flatter and flatter towards 0. That's wider, but it's also, we call that a compression, a vertical compression. Whether it is been reflected, such as this negative indicates, or it's not reflected, it's still a compression until it hits to -1. And if I widen that to like -10, then it'll start being a stretch. So -1 to +1, anything between those values, not including 0, because that just cancels everything out, would be considered a compression. Anything outside of those would be a stretch. And let's go through a couple examples so you can kind of understand what's going on in your assignments. These are some questions that you might have to address later, and some will be multiple choice, but I don't really have all of these as multiple choice because I want you to kind of write a couple things down. So the first example, we want to talk about what, I want you to graph it on Desmos so you can visualize that graph. And I want you to write what those transformations are. So that's going to be part A. And then part B, we're going to describe the characteristics. What's the vertex? Is it a min or max? What's the domain? What's the range? What are the zeros? Does it have an increasing interval? What's the decreasing interval? Describe all that information. So for first part, type it in Desmos. Remember, the parent function is y equals x, or y equals the absolute value of x. So anytime you're comparing it to that, that is what you want to visualize, okay? So if it helps you to graph that first, you are welcome to. I'll go ahead and do that, I guess, so you can remember shift and backspace bar, backslash. There's your parent function. And then I'll go ahead and write y. Sometimes I don't write f of x, I'll just put y in there because it's less typing. I'll put a -2, absolute value of x minus 1, close it up, and then do +4. And let's take a look at this full size. So there's a lot going on here, but let's isolate maybe one thing at a time. So let's say I want to talk about what happens with this negative, okay? So if I just did y equals negative absolute value of x, if I just threw a negative out first, that's going to reflect it over the x-axis. So that first thing, we can write, let me do a different color. So we're going to write reflect over the x-axis. And that's kind of indicated by that negative. So anytime you see a leading negative, it's going to reflect over the x-axis. So now what happens when I throw a 2 in there? Remember that 2, that's going to make it narrower, that's going to stretch it. So it's a vertical stretch by a factor of 2. You don't have to write -2 because we've already accounted for that in the reflection. So it's a vertical stretch by a factor of 2. And you can get lazy and just write vertical stretch and probably be okay with that. So now what happens when I subtract the 1? Well, if I take the 1 away inside the bars, then it actually goes right 1. Remember, it's the opposite of the sign in the x-axis. So it's going to go right 1. Let me turn this thing off for a second. And then finally at the end, it's going to have this +4. And that +4 at the end is going to shift it up. So it's going to go up 4. So those are the movements. Being able to describe those reflects over the x-axis. Let me color code things a little bit. So the reflection is going to be this. The stretch, that's going to be that 2. The right one, that's going to be the -1. And the up 4, that'll be the +4 at the end. All right, let's look at the next part of this. So now we want to describe all of the characteristics of this graph. So I'm going to get rid of this stuff here. We'll just focus on this one graph. And let's take a look at what's going on. So let's kind of, we got a list here, so that's going to help. Let's talk about the vertex first. If you click on the top or bottom point, that would be the vertex. So our vertex in this case is 1, 4. We also have to talk about what that is. So the vertex, in this case, it's a maximum. That's going to be positive 1, 4. It's a coordinate. So we've taken care of that. The domain, that's a gimme. The domain's always going to be all real numbers on these. All real numbers, any value can be plugged in. So with domain, we want to write that, but we want to say it like this. -infinity to +infinity. Domain for absolute values will always be that. Let's talk about range. Now, in this graph here, notice that it goes down, okay? So if it's going down, then the range is going to be y is less than or equal to whatever that highest y value is. So the highest y value is 4. So the range is going to be y is less than or equal to 4. But we don't want to, we don't want to say, and remember that 4 can also be gotten right from there. We don't want to say y is less or equal to 4 and all the time. Sometimes we want to write it in interval notation. So it's going to look like -infinity, because remember the graph is opening down forever. So that's the -infinity. And then it's going to stop. It's going to come to a halt at 4, including 4. So we want to actually bracket that 4 in, because that's part of the range. Let's talk about zeros. Zeros are, where does it hit the x-axis? So it's going to hit the x-axis, in this case, at 2 spots, -1 and +3. So that's pretty straightforward. You can just list them as a list, -1 and 3. You don't need to write the coordinates for those. And 2 more points, increasing and decreasing interval. On the first graph, the parent function, we talked about the increasing interval being on the right side and the decreasing being on the left side. Well, it's been flipped, so it's going to change. So the increasing is going to be the other way. It's going to be on the left side. So the increasing interval is going to be this interval here. Let me highlight that in like maybe black. And that's going to look like this. It's going to be starting at -infinity all the way to the end, all the way until you hit this value at x, which is 1. Remember, it's going to say 1 right there. So it's going to increase from -infinity, because it's going from the left side, all the way till it hits 1. It's going to decrease from 1 all the way until the right side. But the right side, keep in mind that the left and right side, left is going to be -infinity, right's going to be +infinity. We talk about x values, not the y values. It's going down, yes, but the the x value is increasing as that graph is going down. So it's going to, the x value is increasing as the graph is decreasing. So it's a decreasing interval from 1 to infinity. So to recap that, it's going to be decreasing it's going to be increasing from negative infinity until 1. Sorry, I had to adjust my screen there. It's going to be increasing from negative infinity to 1. And think about the vertex as that cutoff point, okay? So that, remember, the vertex is going to be at 1, 4, and it's going down here. So it's increasing until it hits 1, and then it's decreasing from 1 onward. So we'll say parentheses 1 to infinity. Now, can you say less than 1? Sure, you could say x is less than 1, and you could say x is greater than 1 if you like. But typically we use the interval notation for those. All right, so that's kind of a altogether type of problem. Let's do a couple more specific problems. So this graph, it has a transformed graph already. Notice it's not the parent function. It's going to be down here. And we want to come up with the new equation if we were to transform that graph 4 units to the left and 3 units up. So let's talk about just, we can plot it on here. Where's that going to be? So let's figure out where we start. So this graph is going to start at 3, that vertex is going to be at 3, negative 6. And that, of course, is a minimum. And then we want to take that graph 4 units to the left. So if I go 4, it's going to go 1, 2, 3, 4, and 3 units up. 1, 2, 3. So it should look like, if I'm graphing this by hand, it'll just basically be shifted 1 unit over there, something like that. So what's the new equation? Well, we don't really need any of this stuff. We just got to know what that new vertex is. So that new vertex is going to be negative 1, negative 3. So think about that now from the parent graph perspective, okay? Forget about, this blue graph now. If we had started here, it would go left 1 and down 3, right? So left 1 and down 3 is going to be x plus 1, because left is plus, right is minus. So this is really x plus 1. Basically just change that sign. And then, oops, I forgot to put a negative up there. I'm going from negative 6 to negative 3, so that's a negative there. And then it's still going to be down from the x-axis, so it'll be minus 3. So that new function would be like f of x, or y equals x plus 1, and then minus 3. One more example. 2 more examples. The second one is related to this one, though. Which absolute value function has a maximum value at negative 3, 1? Well, I guess the easiest thing to do would be to graph these all and find which one first has a maximum value, and then which one is going to have that point as the maximum value. You can memorize a couple of the rules too. So first of all, if it has a maximum value is going to be a graph that opens down. AKA, it's going to have a reflected graph. So it's going to be reflected if it leads with a negative. So I know that one of these two is going to produce a maximum, whereas one of these would produce a minimum because it would be opening up. So now we can kind of decide between those two which one is going to give me the point negative 3, 1 as that vertex, that maximum value. So if you can't tell from here, we could graph it, but we at least narrowed our choices down between A and D. It's going to be D because this is plus 3, so that's left 3, and then this is plus 1, it's going to be up 1. We can verify that though. So if I did y equals -3, and then do absolute value of x plus 1, you can see that its maximum is 0, 1, so that's not going to work because it doesn't shift left to right, so it's going to be 0, then 1. Whereas the one down at the bottom, to get that fraction, you just do -1 and hit the question mark button, but don't hit shift. It'll put a fraction bar, and then you can right arrow out of there, and then you can do absolute value of x plus 3. Close it up, and then plus 1. And clicking on that point gives you a coordinate -3, 1. It's the highest point in that graph, so it would be a maximum. This, if I graph part B, 2 absolute value x plus 3 plus 1, it'll give me a vertex at that point. But that vertex would be a minimum because it opens upward. So this does have a vertex at -3, 1, but it's a minimum. So that's minimum. So that's not good. So it's going to be that answer choice. And then finally, to kind of recap it, I want to just go over range one more time since we kind of hit that up a little bit earlier. If I have 4 functions here, these are the same answer choices as before. I want to talk about what is the range of each function. First thing you want to do is you want to visualize that graph. So if it's got a negative, it's going to open down. So if it's got a positive leading number, it's going to open up. So this would be an open up. And then this has a negative, so it'll open down. So if you have a graph that opens down, remember the range is y values. So that graph will be y is less than or equal to some number. And we'll write it in interval notation as well. If you have a graph that opens up, such as these two, it's going to have a minimum, so it'll have a y is greater than or equal to some number. And then this one has an open down, so y is less than or equal to some number. Now you can get that number really quickly. It's this part of the vertex. That's either the maximum or minimum y value, because that's where it shifted up or down. So in this case, it'd be y is less than or equal to 1. This case, the same, but it'd be y is greater than or equal to 1. This would be y is greater than or equal to -3. And then this would be y is less than or equal to 1, positive 1. And now we want to write those as intervals. So for less than or equal to, remember it's going down. So we say -infinity until we hit 1, and then put a bracket with it since it's including that. If it opens up, then we put a bracket starting at the lowest value up until positive infinity. So answer choice C, it's going to open up again, so bracket -3, positive infinity. And then finally, last answer choice, it's opening down, so it's going to be -infinity till you get to 1. And I would encourage you, I'm not going to take the time to do it right now in this video, to graph each one of those and verify that those graphs are going to kind of follow those same patterns. And you can click on those points and you can get those vertexes to help you assist with that. But it's always going to be dealing with those last numbers for range. Domain, if it ever asks you for domain, all real numbers. But range will be very specific depending on that top part of the vertex or bottom part. So that's it for the slideshow. Hopefully that makes a little more sense. Try the assignment for you guys and let your teacher know if you have any questions. Thank you.